Okay, welcome to another installation of the NanoFab Edit training videos. In this video we're going to take a look at the top level layout of your design once you're ready to submit your mask for fabrication. So we'll go ahead and get started here. What I've got here is just a cell that I've made up of a bunch of instances here, and we're going to consider this our fabrication cell. So this is the cell that we want to fabricate, we're most interested in. So I'll just go ahead and function F10 here will arrange my windows nicely. So in this we just have some basic geometries and whatnot. It's really irrelevant what this is. This could be anything that encompasses your entire design. So generally what I recommend you do at this point in time is create a new cell. So we'll just go ahead and we'll hit N to create a new cell and give it a name something like top level. And this is the cell we're going to use as a wrapper to perform all of our layout functions in. So we'll just get this into the window here and zoom in a little bit. So at this point in time, it's often useful to change your display units. You may have been working in microns or millimeters prior to this, but at this point in time, it's useful to go to inches. And what we'll do is we'll also use some of the lesser used layers here, the ones without the GDSII numbers. Specifically, I'm going to choose the ruler layer just because it's got a nice outline for me. So on the ruler layer, what I'm going to do is I'm just going to draw a box, and I don't really care how big it is right now because I'm going to use Control E to edit the properties of this box. And I'm going to center it at the origin, so that's going to be 0, 0. And I'm going to make the width 5 inches and the height 5 inches. I can use 5 and 5 here because my design units are inches now. So I'll say OK. And what we get here, I'll just zoom in a little bit more. Oops. Is an outline of what your 5x5 mask would look like. So another thing that is useful at this point in time is if you're going to be working with a 4-inch wafer, you can also place the outline of a wafer here. So again, we'll just draw a circle, hit Control E, we'll center it at 0, 0, and we will give it a radius of 2 inches, which will equate to a 4-inch diameter wafer. So here you can see we have a nice outline of what our mask is going to look like and what our wafer would look like if it was centered underneath the mask. So at this point in time, what we can do is just go ahead and fill up the design area with our fabrication cell. So we're going to use fab cell, and you can see right there, there's a very, very tiny little spot where our cell has been instanced. So it doesn't take up very much area on our mask, and so what we want to do is essentially fill the area. This is just going to allow us to get multiple copies of the same design, and we can test for various things like uniformity across the wafer. So again, using Control E to bring up the Properties or Edit Objects window, we are now presented with our instance window, and what we're going to do is simply create an array of objects, and I'm just going to sort of guess and test here with the size of the array until I get something that generally fills up my wafer. So that one didn't quite do it yet, so I'm just going to maybe bump this up to 300 by 300 or so. And this might be a little bit too big, but we are getting into the ballpark here. So one more time. On the X dimension we're a little bit big, so maybe we'll say 250. And in the Y direction looks like we can go a little bit more, so maybe 350. And got a little bit of overhang there. Third time's a charm, I guess. Perhaps I should have sorted this out before I started recording, but that's okay. We'll say 230 by 330. Good enough. So you can fill the area of your mask as you see fit. You might be dicing, so you might want to fill the areas into sections that you're going to dice and align it a little bit differently. But for my purposes, I'm just going to try to fill the entire surface of the wafer. I mean, you can see there's other areas here. If we wanted to, we could actually add another instance of fab cell and array that one maybe into a longer array of, say, 75 by 25 or something to that matter. And then we can take these little pieces, and you can essentially fill up the entire wafer like so. I'm going to leave it at that for now. Hopefully that sort of gives the idea of how to fill up the area. Okay, so now at this point in time, it's worthwhile pointing out some details about what we're doing as we are filling up the area of our cell. Now initially, before I added this other piece up here, it's pretty easy to see that this light gray outline here contains our actual design. Now, just remember that the wafer and the mask guides here, they're not going to be fabricated. They're on layers that won't be exported, so you kind of just have to put them out of your mind. They're just there to guide you in terms of how, what kind of area you have to work with. But the design borders are going to be determined by the actual area or the boundaries of what is exported. So in this case, what we've done is we kind of have created ourselves a design border, and I'll just try to indicate it here with a separate box, which is going to look something like this, because we added that little piece up at the top there, which means that the center of our design is not actually going to be in the center of the mask as we expect it. So we'll just look at a little illustration here which sort of highlights what's going on here and why things might get shifted away from how you expect them to be. When you create your design in LEdit, a few videos back we talked about designing around the origin and how that wasn't necessarily important, because when you fabricate your mask, the pattern generator is going to automatically center your design in the middle of the 5-inch square mask. Now the question is, how does the pattern generator determine what's the center of your design? Well, it doesn't recognize the difference between your actual design or your text labels or your alignment windows or anything like that. So what happens is you have your design, which can be any arbitrary features, and the boundaries are determined by the edges of that, which will make the center in this case be right about there. Now what happens is when you start adding alignment windows, say at the bottom or at the side, that shifts the center because the design boundaries are now moved, which causes the center to move, and as you can see here, the whole design area gets shifted to the upper left. So you can avoid this by adding offsetting design windows at the other side, which will then place the center back where you expect it to be, and then the overall design boundaries will cause the center of your actual area of interest to be in the center of your mask. And that's sort of something to keep in mind when you start adding features around the outside of your existing design. Okay, so hopefully that clears up a little bit what's going on when your design is centered on the mask during fabrication. So that being said, now we'll just go ahead and remove that boundary there. And so another thing to consider at this point in time is going to be the polarity of your mask. There are two options for submitting your design. You have inverted mask, which basically means that all of the polygons in your design, if we just zoom in here, those would be the orange bits in this case. All of the polygons are going to be chrome on your mask, meaning that they're going to be opaque. Also, you have a non-inverted mask where the polygons are going to be glass, so that means they're going to be transparent. Now keep in mind that the masks start out as a glass substrate with completely covered in chrome. So anytime you want to make something transparent or glass, the laser has to write that area, which clears it off, which obviously increases or decreases your write time appropriately. So if that being said, if you have the case where your mask is going to be non-inverted, meaning that the polygons are going to be chrome, that means that the other areas of your mask where you don't have polygons are going to be opaque, so you won't be able to see through them. And that's sort of the reason why we may use alignment windows, just so that we can see the edges of our mask and make sure, or sorry, the edges of our wafer underneath our mask during lithography to make sure that it's roughly centered underneath the mask. So what we can do for that is just add a couple of boxes. Again, I'm just going to kind of arbitrarily draw them here and then use Control E to edit the properties. So I'm going to set the center of this one on the X origin, and the Y I'm going to make -2 inches, so that should place the edge of the wafer in the middle. We'll make it about 2 inches long and maybe about 1/4 of an inch tall. So there is one window, so that will be transparent if this was a non-inverted mask, meaning that we will be able to see the edge of the wafer through there. And then we can just copy paste, Control R, we'll rotate that, Control E, and we'll just place this one on the 2 inches on the X, and we'll center it on the Y axis, and there we go. So you can see that this is the shape that we had in the little illustration there, and that's why we caused our center to be moved off. So keeping that in mind, what we'll do here, just for simplicity's sake, is we will duplicate these two shapes again. So I'm just going to Control C, Control V them. I did not mean to get the extra wafer in there, so we'll grab these two guys here again. And we're just going to rotate them, let's say 180 degrees this time. And of course we could do this individually. And I'll just make sure that these are in the center. So now we're going to make X0 and Y2. And on this one we'll make X minus 2 and Y0. So there are our 4 windows. Just the reason we have 4 of them is to make sure that our design boundary is going to be set in the center there. Now anything we do inside of these windows, it's not going to matter. The center of this design will still be right here. So now we can also add some text if we wanted to. So if we remember our layout generators, we can go ahead and add some text to this. We can say, my mask. We can put it on layer 1, cell name. We can add the date, any of the features that we went over here before. We'll just make this 1 inch tall. It's complaining about the resolution because we have too many zeros. We'll just say okay, it's fine. And we're going to drop that down right about there, I think. And that is huge. So, again, we'll just scale that down a little bit. Maybe make that 20% of its size. And we'll just drop that off of the printable area of the wafer, because we don't actually want that to show up on our substrate, but we do want it on the mask, and we want it within our design boundary there so that it doesn't alter the center. So you can use areas like this to add any type of identifying marks that you wish to have on your mask, however not on your substrate. So now we have everything lined up. We're going to say that we're finished here. This is we're happy with this. Now we're going to get everything packaged up and ready for fabrication and shipped off. So this is where that GDS2 number comes into play. In our case, we only have 1 layer. We've only drawn on layer 1, or layer 13 in this case. So when we submit our mask, we are going to keep note of that number right there. If you had multiple layers, you are going to go through this process a couple of times, because you're going to need to submit 1 fabrication request for each layer that you have drawn on. So the first thing we'll have to do is we are going to export this design to a GDS2 file. So that's pretty straightforward to do. We're going to go File, Export Mask Data, and we're going to select GDS2. 2 file names, so this is going to be the eventual output of our file. We're going to just call it Final Layout. We'll stick it on the desktop. It's a GDS2 type. We don't need to zip it. The log file, it does generate a log file. You can save it if you like, or you can just simply view it in a log window. Generally, I just like to view it and sort of make sure that everything looks okay during the export. Now, there's a bunch of different options here. Generally speaking, the default options are going to be fine. Some of this stuff gets into some more advanced features and functions that we haven't really covered yet. So we're just going to stick with the defaults here in terms of the checkboxes. In this option here, we have a fracture. So in one of the videos a while back, we talked about curves and polygons and how your curves are approximated, and those approximations of the curves can result in polygons with a lot of vertices, which can cause some problems when we go to the pattern generator. So by checking this box, what the software will do when it exports your design is it will fracture any polygons that have more than 199 vertices into groups of smaller polygons. The resulting feature will be the same, however, no polygon within that group will have more than 199 vertices. GDS units, this one you don't want to touch at all. You want to leave at the default. Changing this can result in changing the scale of your design, and we don't want to do that. The cell names, in this case, basically we can preserve the case. You do want to restrict the cell names to 32 standard characters. The pattern generator itself is a little bit pickier when it comes to naming of your cells within your design. So this will sort of allow the software to automatically rename or change things as appropriately. And finally here we have export cell. We want to choose selected cell and its hierarchy, and we want to select our top level cell. What that will do is that will export the top level cell and any cells that you have instanced within that cell necessary to create your design. So what that means is it will exclude cells that you may have been just testing out different things or playing around with it. None of those other cells will be exported and included in the final GDS2 file. Now keep in mind as well, this GDS2 file will contain all of your layers, so if you do have multiple layers in your design, you only need to have one exported file. You do not need to export a new GDS2 file for each layer. They will all be contained in this single file. So we'll go ahead and we click export. Now we're just going to go ahead and look through our log file here and make sure that everything's okay. We do see that we have one warning here. We see that it found objects on cell or in cell top layer on layer ruler with no GDSII number, and it ignored these objects. That's fine because we know that we created two guide objects on that layer. We created the mask outline and the wafer outline, and basically this log is just telling us that those objects were not exported, and that's fine. So everything looks okay. Now, the next step here is just sort of a sanity check. What I recommend doing is simply just closing everything down here. And what we're going to do is we're going to re-import that file that we just exported just to have a look at it and see what we actually got. This is also the same method that you would use to import any GDS2 file if you wanted to take a look at it. So we'll import our GDS2 file. And we're going to go ahead and browse. We threw it on our desktop, and I guess we called it top level. I thought we'd call it something else, but that's okay. And down here, it uses setup file. Generally, you should have something called ledit.tdb in your choice of options here. This is the standard design environment. If you import it into this design environment, everything, your layer names and numbers will all match up. If you use a different layout file, you may get some warnings. We'll go through those in a little bit, but we'll just go ahead and use the ledit setup file, and we'll import. Our import log shows no errors, no warnings, and so here is what we actually end up with. Now you notice that those guide layers do not show up, so we don't have the wafer or the mask outline. And if we zoom in here, this is a good time to go through and zoom in and make sure that everything looks like you expect it to look. Make sure all your features are there, make sure that everything showed up as you expected, because this is the file that you will be sending to us for fabrication. You'll also be able to notice any differences between curves that you may have drawn in their native shapes and how they translated into approximations at this point in time as well. So this looks fine. We're satisfied with this. The next step is going to be to submit that file for fabrication. So in order to do that, you will need a NanoFab user ID or username and password, which you can get through our website. And once you have that, the submission process is fairly straightforward. So we're just going to go to nanofab.ualberta.ca, and there will be a link up here for photomasks, and that will bring you to our mask submission system. So we will go ahead and log in. When you log in, you'll receive an update or notices, any notices that are applying to the system. You'll get notices right there. Now this is the mask fabrication request form. So from here, basically, what the first thing you need to do is select a project that you're going to essentially bill the charges to. To get set up for this, again, is something that needs to be done ahead of time. You need a mask authorization form, which can be downloaded from our website and then is signed by your supervisor or account holder, whoever is responsible for paying the bills. And once you've selected your project, you will go ahead and choose the GDS2 file that we exported, which we called toplevel.gds. So we'll open that. Now here's where we need to supply the fabrication information. So in our case, the final cell name was top level, and that is the cell that we want to fabricate. If we specify the wrong cell name there, we may end up fabricating only a single instance or some other smaller part of our design, and we really don't want to do that. Now the GDS2 layer number here, this comes back to those layer numbers that we had here. So in our case, again, we only have a single layer, and it's layer 1, and the GDS2 number for that is layer 13. So in this spot here, we'll put 13. The pitch, now this is just used as a guideline for the processing staff when they do the development of the mask. So it is a rough indication just for them so that they have an idea of how fine the features are on your mask. It doesn't have to be precise. In our case, mine was about 10 microns. Now here we have a selection for the exposure mode. Now we mentioned this just a little bit earlier. We have the inverted, which means your polygons are going to be chrome or opaque, and we have non-inverted, which means your polygons will be glass or transparent. So an an inverted mask would look something like this, whereas a non-inverted mask would look something like this. So depending on your processing and your steps, you have to choose the appropriate exposure mode for you. We'll choose non-inverted. Now we have another selection here, orientation, which is RRCD or RRCU. That stands for read, write, chrome down, read, write, chrome up. The descriptions of these options are found a little bit further down here on the page, but essentially this has to do with flipping your design on the y-axis. If you have a symmetrical design, this is kind of a moot point, but if your design is asymmetrical, that means if it has any text, any lettering, anything that you need to read, you need to keep in mind that when you do your lithography, you're going to want the chrome side of your mask facing down as close to the substrate as possible. So in flipping your mask upside down, there's an inversion there, and so to compensate for that, generally speaking, what you will select is read, write, chrome down, and that will flip your design on the y-axis before it's printed, so that when you flip it on the y-axis to do your lithography, it ends up being in the correct orientation that you expected. If you're doing backsign patterning, you might choose read, write, chrome up, or if you have some other special needs, you can make that choice as necessary. The other ones are they're actually not options. Basically, you're going to use the 4mm lens. Print and process is the service that's offered by the NanoFab. That means that we're going to not only write the mask on the pattern generator, but also develop it, and you're going to receive a product that is ready to go and ready to use. Compiled, again, is an advanced feature. There is one more step after submitting the GDSII file, and that involves compiling it into stripe files or machine files for the actual pattern generator. It's another advanced step that some advanced users could perform, but generally speaking, the NanoFab staff will take care of that for you, so you just can select no. Then what you do is you can add any comments that you may have. These will be seen and submitted with your mask, and then just simply click submit. You'll get a notification your mask is being submitted, and what you can do is you can now view the mask queue. So this is a current look at the mask queue. So any masks in the top section here are in currently being processed. They have a little status here and some details in terms of the fabrication status. Any masks that you see below here have been completed, the status is done, and they are ready for shipping or pickup here in the NanoFab facility. You can check on the status of this queue at any point in time just by logging into the system. That button I clicked there actually filters it, so it only shows your masks if it gets a little bit much to look at. But by clicking Submit Mask, basically, and going to the mask queue at any point in time, you'll be able to check on the status. In addition to that, you will also receive email notifications as the status of your mask changes and it goes through the process. Finally, you'll get one that says done, and then you can either come and pick up your mask, or if you're from out of town, it will be shipped to you once you provide the appropriate shipping information. And that is the end of the process. We will be carrying on with the video series here just to get into some more advanced topics in terms of editing and using L-Edit, but essentially that is it. Once you've submitted your mask, you are done. If you did have multiple layers in your design, you would simply submit another fabrication request using the same GDSII file, same cell name, and what you would be changing is this GDSII layer number. So if you wanted to then fabricate, say for example, layer 2, you would put in number 51 there and submit it. In our case, we don't have that, so if I was to go through with this, we would generate some errors. In any event, I hope this video has been helpful. Thanks for watching, and stay tuned for some more.